Assalamualaikum and hi everyone. We are group 16 from class 3B. In this video, we will present our group assignment for subject CSC520 Principles of Operating Systems, titled The Different Aspects of the Unix and Windows Operating Systems. My name is BALQIS binti Muhammad AZMINOR, and joining me for this presentation is my group members, which is Anim binti and SYAFIQAH binti JAAFAR. Now, let's move on to the presentation. An operating system is defined as a program that lets the user to interact with the computer through the use of software program and hardware. There are essentially two main methods for doing this. Use of a command line operating system or command line interface, CLI, such as Unix or Linux comes first. Solaris, macOS, and AIX are some examples of Unix. The usage in a graphical interface such as Windows is the other. In conclusion, Unix relies on commands, whereas Windows relies on menu. Both running systems have their benefits and drawbacks. The user must determine which will best meet their computer needs. Users should be aware of how each system functions and what it is designed to do in order to determine which system is ideal. Now, I will explain on the differences between Unix and Windows in terms of inter-process communication. In general, the operating system typically provides a form of mechanism called inter-process communication. This mechanism's primary objective is to facilitate communication between multiple processes. In short, intercommunication enables one process to inform another process that a certain event has occurred. The differences between Unix and Windows in terms of inter-process communication includes its characteristics. Unix has several inter-process communication mechanisms that contain distinct characteristics which is suitable for different situations. For instance, shared memory, pipes, and message queues that are suitable for processes that are running on a single computer. Shared memory and message queues are appropriate for communicating among unrelated processes. Windows, on the other hand, have no counterpart in Unix. Unlike Unix, Windows has shared memory, pipes, and events that are equivalent to signals which are suitable for processes that are local to computer. The shared memory is based on file mapping to be used across the network. In terms of process, Windows and Unix are a multitasking operating system that must be in charge of many processes at one time. Each process will have its own data, system code, state, and resources. Virtual address space, synchronization objects, and virtual address space is included in the resources. In terms of process, the distinction between Unix and Windows is the way both of these operating systems does multitasking. Originally, Unix was designed to be a multiprocessing system, which means that a user will have many processes running at once, which will result in an efficient process. Windows has evolved from its beginnings on Microsoft MS-DOS, which, on the other hand, does not hold up preemptive multitasking. Subsequently, Windows relies heavily on threads instead of processes. That's all from me. Now I will pass the presentation to SYAFIQAH to explain on threads.
Next, I'm going to explain the comparison between Windows and Unix based on the thread. On the Windows operating system, a thread is a dispatchable unit of work that performs sequentially and is interruptible so that the CPU can switch to another thread. In order to run, a Windows process needs to have at least one thread. The thread may then start a new one. Multiple threads of execution inside a single process are likewise supported by Windows. The same process can have several threads running on various CPUs at once. To handle requests from several clients at once, server processes may employ multiple threads. Multiple threads from the same process may run concurrently in a multiprocessor machine. On the other hand, the conventional Unix process model only allows for one control thread per process. This is theoretically equivalent to a thread-based method where each process is made up of a single thread. When a program uses pthread, it starts off with just one process and one thread of control. The behavior the program displays while running should be the same as the behavior of the standard process up until further thread of control are added. Next, we move on to the comparison between Windows and Unix in terms of their CPU scheduling. Windows is made to be as responsive as it can be to the demand of a single user operating system as a server or in a highly dynamic environment. Windows uses a preemptive scheduler that has adjustable priority level, round-robin scheduling within each level, and for some level, dynamic priority modification based on the activity of the current thread. Instead of using processes for scheduling, Windows uses thread. For the Unix operating system, the Unix scheduler belongs to the round-robin scheduling with multi-layer feedback class of operating system schedulers, which mean that the kernel assigns the CPU to a process for a time quantum, preempt a process that exceeds its time quantum, and feed it back into one of the multiple priority queues. Before it is complete, a process may go through the feedback loop numerous times. When the kernel switches context and restores a process context, the process picks up where it left off when it was suspended. In multi-processing operating system, synchronization of running processes is crucial. Windows offers dispatcher object to synchronize thread using a variety of technologies such as mutexes, semaphore, events, and timers. The system safeguards shared data by requiring a thread to take ownership of a mutex before accessing it and then releasing the ownership after access is complete. When a global resource is accessed on a single processor system, the Windows kernel momentarily must interrupt for all interrupt handler. Windows employs pinlock on a multi-processor system to safeguard global resource for a short code segment. The kernel meant that a thread is never preempted while it is in possession of a spinlock for efficiency. On the contrary, Unix offers a number of process synchronization algorithms that combine shared memory and message transmission technique. These mechanisms serve as a gateway for the transmission of message between processes. Process synchronization via message passing is a natural solution in system topologies with numerous processes that do not share a memory unit.
Hi, my name is Anim and I'm here to explain the differences between Windows and Unix operating system in terms of memory management and operating system. So the first one is memory management. Memory management is handled differently in Windows and Unix. First, Windows uses a body system for memory management, allocating memory in fixed task blocks. Cluster demapaging is used by Windows to bring in memory as needed. The working set notation is used by window paging system. It contains pages that are in the main memory, and the working set size is adjusted in accordance with those pages. The page replacement mechanism is a crucial component of any memory management system. Windows page replacement use the principle of first in, first out. On the other hand, Unix manage memory using visual memory and paging. The kernel use visual memory to treat a file on the hard drive as if it were in memory, and paging to transport the data between physical memory and disk storage. Memory mapping lets the kernel use disk storage as physical memory. The kernel links visual addresses to physical memory for each process. To conserve memory, the kernel employs demapaging to load process page only when needed. And the last one is file system. There are several differences between the file system used by Windows and Unix-based operating systems, including file naming convention, file permissions, file hierarchy, case sensitivity, hidden files, and volume management. Windows use drive letters and simple read or write or execute permission system, while Unix use a forward slash and a complex system of user, group, and other permissions. Next, Windows use a single root directory and is not case sensitive, while Unix use a hierarchical file system and is case sensitive. Windows use the hidden attribute as proprietary NTFS and FAT32 file system, while Unix use a period to indicate hidden files and more open and portable file systems such as ext4, xfs, and zfs. And lastly, what we can conclude from this video is both Windows and Unix are operating systems, yet they differ significantly in some important ways. While Unix is an open source multi-user operating system, Windows is a proprietary operating system created by Microsoft. Unix is often used on servers and mainframe, whereas Windows is intended for users on desktop and laptop. While Unix employs a command line interface which is CLI, while Windows uses a graphical user interface which is GUI. Unix is renowned for its reliability and security, but Windows is typically thought to be more user-friendly. And lastly, Unix is more common in the scientific, academic, and technical domains, while Windows is more prominent in the consumer and corporate markets. So this is the end of our video. We hope you guys found this video useful, and thank you for watching. Don't forget to give us thumbs up. Bye. Assalamualaikum.